Here's problem 36. Two long parallel wires are separated by 4 centimeters. One of the wires carries a current of 20 amps and the other carries a current of 30 amps. Determine the magnitude of the magnetic force on a 2-meter length of the wire carrying the greater current. Well, let's imagine our two wires here. And we'll say that the current in one wire, I1, is equal to 20 amps. And we'll have the current going in the other wire in the same direction. We weren't told which direction it's going, but it doesn't really matter as far as the magnitude of this force is concerned. So we'll just have it go in the same direction. And that means there will be an attractive force between these two wires, equal and opposite. So they both will feel the same force. So it doesn't really matter what the magnitude of the force on the greater current is. They both are going to feel the same magnitude of force. And the value of that force is going to be equal to mu naught I1, I2 times L, the length of the wire in question, over 2 pi times D, where D is the distance between the wires. So in this case, we have mu naught, which is 4 pi times 10 to the minus 7 times 20 amps times 30 amps times a 2-meter length over 2 pi, and the distance between these is 4 centimeters. 4 times 10 to the minus 2 meters. 4 pi divided by 2 pi will leave us with a 2, and the 20 divided by 4 will leave us with a 5 up here. So I have 2 times 5, a 10, 300, 600 times 10 to the minus 7 over 10 to the minus 2. So that is going to be 6 times 10 to the minus 3 newtons. And that'll be the force on the greater current, wire carrying the greater current and the wire carrying the lesser current. And as we've drawn it, it'll be attractive. But if they're in opposite directions, we'd have the same magnitude force, but in opposite repulsive fashion. So 6 times 10 to the minus 3 newtons is our answer.